Hello everyone, I hope you're doing well today. Today we're going to learn how to graph logarithmic functions, but before we can get into graphing logarithmic functions, we need to know how to evaluate a logarithm. A logarithm has three basic parts to it, or three basic elements. I read this as log base b of a equals x. B is the base, a is the argument, and x is the exponent. I can rewrite any logarithmic equation as an exponential equation as b to the x equals a. Now we can use the form of a logarithmic equation to be able to evaluate the logarithms. So we ask b to the what power is equal to a. So if I look at log base 2 of 64, I would ask 2 to the what power is 64. So I have 2 to the x equals 64. Well, if I think of my powers of 2, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, and 2 to the sixth is 64. So log base 2 of 64 is equal to 6. Looking at the second example, log base 6 of 216 equals an unknown. So I can rewrite that as 6 to the what power is 216, or 6 to the x equals 216. 6 to the first is 6, 6 to the second is 36, 6 to the third is 216. Therefore, our logarithm evaluates to 3. Log base 6 of 216 is 3. Our final example, we have log base 3 of 1/27 is equal to 1. So I would take my base 3 to the what power is 1 over 27. Well, since my exponential equation is equal to a fraction, I know that my exponent is going to be negative. Remember, when we look at a to the negative n, it's equal to 1 over a to the n. So I know that my exponent is going to be negative. Well, 3 to the what power is 27? 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. Therefore, log base 3 of 1/27 is equal to negative 3. Please take a moment to pause this video and record these examples in your notes. Now that we know how to evaluate logarithms, we can use that knowledge to be able to graph logarithmic functions by making and plotting a table of values. When we look at the example f of x equals log base 4 of x, we now know how to evaluate log base 4. When we create our table of values, we're going to want to look at our base and make sure that our values that we input for x into our argument are powers of our base. So I'm going to create a table of values, and for my x values, I'm going to choose, 4 to the negative second would be 1/16 as an argument. 4 to the negative first is 1/4. 4 to the 0 is 1. 4 to the 1 is 4. And 4 to the second is 16. So I want to choose these 5 values of x to plug in as my argument and evaluate to get my y. So if I start off with log base 4 of 1/16 and evaluate it, I'm looking for 4 to an unknown power equals 1 over 16. Well, 4 to the negative second is 1/16. Therefore, when I input 1/16, I get an output of negative 2. Now I want to evaluate my function when I input 1/4. So I do f of 1/4 equals log base 4 of 1/4. Well, to evaluate log base 4 of 1/4, I'd be saying 4 to the what power is equal to 1/4. Well, 4 to the negative first is 1/4. Therefore, our output or y value is -1. Next, I would input 1 in as the argument of my logarithm. So I would be evaluating log base 4 of 1 equals an unknown number. Well, that would mean that 4 to an unknown power is equal to 1. Well, if anything to the 0 power is equal to 1, therefore my output value is 0. Next, I would evaluate my function when x is equal to 4. So I'd be evaluating log base 4 of 4 equals what? Well, that means 4 to an unknown power is equal to 4. Well, 4 to the first is equal to 4, therefore my output value is 1. Note, whenever you have a base and an argument that are equal to each other in a logarithm, it is always equal to 1. So log base b of b is equal to 1 for any logarithm. Finally, I would evaluate my function when x is equal to 16. So I'd have log base 4 of 16 equal to an unknown number. Well, that means 4 to an unknown exponent is equal to 16. Well, 4 to the second is 16, so that means my output or y value is 2. Once you've completed your table of values, your next step is to plot and connect the points. When you make your graph of a logarithmic function, notice the left-hand side of the graph is approaching -infinity for the y values. Our graph is going to get very close to the x-axis, but never touch it. It's going to keep going that way because whenever we evaluate a logarithm, we can never get a negative number. Please take a moment to pause this video and record this example in your notes. Before we wrap up today's lesson, I'd like to try one more example with you. Let's graph f of x equals log base 1/5 of x. Again, we need to create a table of values to graph this function, and we want to be very careful about what values we input to our function for x. The values that we input should all be powers of 1/5. Well, I know that 1/5 is a power of itself, because anything to the first is itself, and 1/25 is also a power of 1/5, because 1/5 squared is 1/25. 1 is a power of any number because anything to the 0 is equal to 1. Now, if I evaluate 1/5 to the negative first, I'm going to take the reciprocal of my fraction. The reciprocal of 1/5 is 5, and make the exponent positive. So that means 5 is also a power of 1/5. If I evaluate 1/5 to the negative second, I would end up taking the reciprocal, again 5, and making my exponent positive 2. 5 to the second is 25. Therefore, 25 is also a power of 1/5. Now now that we have our values selected for our table of values, let's start plugging them in. When I plug in an input of 25, I get f of 25 equals log base 1/5 of 25. Well, if I'm evaluating log base 1/5 of 25, I would rewrite it as 1/5 to an unknown exponent is equal to 25. Well, we already know 1/5 to the negative second equals 25. Therefore, our output or y value is -2. Now let's plug in an input of 5. So I'd have f of 5 equals log base 1/5 of 5 equal to an unknown number. Well, that would mean that I would take 1/5 to an unknown exponent equals 5. We already know that 1/5 to the negative first equals 5. Therefore, our output value when I input 1/5 is -1. Next, we'll input 1. When I input 1, I get f of 1 equals log base 1/5 of 1. When I evaluate log base 1/5 of 1, I rewrite it as 1/5 to an unknown value, or unknown exponent, equals 1. Well, anything to the 0 power is 1. So 1/5 to the 0 equals 1. Therefore, our output value is 0. Next, we're going to evaluate when our input is 1/5. So I have f of 1/5 equals log base 1/5 of 1/5. Well, if I'm evaluating log base 1/5 of 1/5 equals an unknown number, well, I notice that my base and my argument are the same. Whenever that happens, remember that our log is equal to 1. Therefore, our output value is 1. Finally, I need to evaluate when my input is 1/25. So I have f of 1/25 equals log base 1/5 of 1/25. When I evaluate log base 1/5 of 1/25, I rewrite it as 1/5 to an unknown exponent equals 1/25. Well, when I square 1/5, I get 1/25. Therefore, my output value is 2. Once you've completed making your table of values, you can plot them and connect them to graph the logarithmic function. Notice that this function is a little bit different than the one before. We have a base that is less than 1. When we have a base that's less than 1, our graph on the left-hand side is going to approach, for our y value, positive infinity. And it's going to get very, very close to and keep getting closer and closer to the x-axis, but never cross it or go past it. Please take a moment to pause this video, record this example, as well as any questions that you may have in your notes, and I will see you in our Zoom meeting shortly. Take care, stay safe, and be well.